Hello. In this video, I'll show you how to easily get started with Lucee in Docker. I will be using a project that I recently published on GitHub, and I will show how to easily build custom Docker images and run containers from those images. If you're unfamiliar with the terminology, a Docker image defines the blueprints for a container, and a container is an instance of that image. So conceptually, it's similar to the relationship between a class and an object in object-oriented programming. Everything I show here is cross-platform and works similarly on all the major operating systems with slight variations of paths and permissions. The only required software is Docker, and we can check if it's installed by running the command docker -- version. As you can see here, running that command on my machine shows the Docker version information. If instead you get an error on your machine, go to the Docker website and install Docker. Let's start by downloading the project from GitHub. One way to do it is to go to the project page and click the download zip button. If you're comfortable working with Git, however, you might find it more convenient to run the git clone command. Running the git clone command, I got the project downloaded to the Lucee Docker directory. Let's go into that directory. And now we're ready to build a Docker image for Lucee. The basic command is docker image build dot, and the dot is not a typo here. It tells Docker to use the current directory as the context for the image build. The rest of the arguments that I show you are optional, but are very useful, so let's see how they work. I will use a -t switch to tag the image as isapir, which is my username, /lucee-538. Tagging the image allows us to refer to it easily later, instead of using some random name or unique identifier. I will set the build arg Lucee version to be 5385 snapshot, set the build arg Lucee admin password to change it, and I'll also set the Lucee extensions build arg with the unique ID of the WebSocket extension. That will install the WebSocket extension at build time, so that when we run the container, the extension is already installed and we don't have to wait for it to be downloaded and installed. You can get the full version information and the IDs of the extensions from the Lucee download page. So you can see here, for example, the version information, and each extension has a unique identifier. So let's copy that command, and just before I run it, let's make sure that I don't have any images installed locally by running the docker image ls command. As we can see, I do not have any Docker images installed locally. I will paste the command here and hit enter. And that's all we have to do. Docker will now download everything it needs in order to build the image. And as part of the build process, it will download Lucee and whatever extensions that we specified, set the Lucee admin password, and launch Lucee for a warm-up. Doing the warm-up at build time allows us to later launch the containers fast because we don't have to wait for any initializations and one-time setups. The first time you run the build process, it takes longer than subsequent runs because nothing is cached locally and everything needs to be downloaded. As we can see from the image build log, the last messages are that the Lucee warmup completed and that the image was successfully built and tagged. Once you've built a Docker image, you can optionally push it to a Docker repository, like Docker Hub. Doing that will allow you to later run that image from any machine without building it again. So now that I built the image, let's launch a container. The command is docker container run. We will map the port 8080 on my local machine to port 8080 inside the container. And we'll give the container a name so we can easily refer to it as Lucee-8080. The last thing to do is to specify the image that we want to use for the container, and we'll use the one we just built and tagged as isapir /Lucee-538. So let's copy that command and run it. And that launches the container and it's ready for use within a couple of seconds. Once the container is running, we can go on our local machine to localhost at port 8080 because that is mapped to port 8080 in the container. As we can see here, this is the welcome page from the project. It shows that we're running Lucee version 5.3.8.5 snapshot. And if we log into the Lucee admin using the password that is specified, change it, we can go into the extensions page and see that the WebSocket extension is already installed. But most likely you would want to run your own code in the container. And there are two options to do that. The first one is to package your code with the image when you build it. That's typical for production use because the code there doesn't change. The second option is to map a directory from your local machine to the container at runtime. That's great for development and troubleshooting, as changes to the code on your local file system are reflected immediately in the container. Let's look at packaging your code with the image first. That is done by replacing the contents of the app directory from the Lucee Docker project with your code and then building the image. If you look at the app directory, there is a README file that says very clearly it is safe to delete the contents of this directory. Let's see an example of how that works. Let's first show a directory listing of the app directory. We can see that in addition to the README file, there is an index.cfm file and an res directory which contains static resources like images and style sheets. Let's go ahead and remove those files. And now let's open Visual Studio Code in the directory. I will create a file called index.cfm and copy and paste some example code into it. And all that code does is return a JSON object with a time in ISO format and the short name of the time zone. Now let's build the Docker image with this code and tag it as isapir/lucee-time. This time the build command runs much faster because we don't have to download things that we downloaded earlier, like the images for Java and Tomcat. And now that the build process completed, we can launch a new container from that image. I will use again the docker container run command, and the only difference is that this time I will map port 8081 on the local machine to port 8080 in the container. Let's go ahead and launch the container. And now we can visit localhost at port 8081 and see that we get the expected information with the time and time zone in JSON format. And when I reload the page by hitting F5, you can see that the time is updated. Now let's look at the second option of running your own code, by mapping a directory from the host machine to the container. This time, we do not need to make any changes to the image, and we can reuse the image that we built in the beginning of the video. But this time, when we launch the container with Docker container run, we will add the -v switch, which will map a volume from our local machine to the container. The format of the -v arg is -v, the path on your local machine, colon, and the path inside the container. The image is configured so that the app is expected to be at /srv/www/webapp/root. So when we map our local directory, we need to map it to that one. One thing to keep in mind is that the container is running a flavor of Linux, so that path is case sensitive. Let's see an example. I will create a test directory named test app on my local machine and open it in Visual Studio Code. I will again create a file named index.cfm and enter some sample code into it. So we'll say something like hello from Lucee in Docker, and insert a cf output tag. The time is now. Let's save the file. And again, this time I will not build a container. I will simply reuse the image that we built earlier and tagged as isapir/lucee-538. The only important addition is the -v switch, which will map my test app directory to /srv/www/webapp/root. The only other difference is that I will map port 8082 on my local machine to port 8080 in the container. This is because the other containers that we launched earlier are still running, and ports 8080 and 8081 are still in use. Let's run the Docker command. And once the container is running, we can go to localhost port 8082 and see the output of the code that we just wrote in the test app directory. But this time we can go back into the test app directory, make changes to the code, and see it reflected immediately in the container. For example, we can add the lucee.server.version information, save the file, hit reload in the browser, and see the change. Or as another quick example, we can add the time zone name by calling the getTimeZoneInfo function and retrieving the short name property. And again, save the file, switch the browser, hit reload, and see our change reflected immediately in the code. So here are links to other resources like the Lucee homepage, source code, documentation, Jira, etc. And I hope that you liked that video. If you did, please connect, comment, like, or subscribe. Thank you.